Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to learn about how to calculate the number of signals and what is integration ratio in NMR spectrum or NMR spectroscopy. So we'll understand first the concept and then we will solve all these examples. We'll try to calculate the number of signals and we'll also find out the integration ratio. Plus we will also solve some previous year questions based on these two topics in JAM exam that were asked. So coming on to the number of signals in 1H NMR spectrum, how do you calculate the number of signals or how many peaks will be visible in NMR spectrum? In last video we had seen what is NMR spectrum. It is a plot of delta, that is chemical shift, versus the intensity of the intensity. Okay, so the first very important thing that the number of signals depend on is the chemical environment. Now what is the meaning of chemical environment? Chemical environment means the chemical bonding, okay, chemical bonding in the molecule, or we can say the bond connectivity. Okay, bond connectivity. If the bond connectivity or the chemical bonding is same, then it will, that group of proton, we say it is chemically equivalent. Chemically equivalent means equivalent or same. Okay, let us understand this with an example. The very simple example of, let's say, benzene ring. Okay, here we know there are 6 protons. Okay, and if you see the chemical bonding means how they are bonded in the structure. So if you see, all the hydrogens, they are attached to an sp2 hybridized carbon. Okay, all the 6 hydrogens are attached to sp2 hybridized carbon. Okay, so we can say all the 6 hydrogens are chemically equivalent. So how many signals we will get? We'll get to see one signal of how many protons? 6 protons. Okay, in this way you write the number of signals and in bracket you write the number of proton for that particular signal. Okay, let us take one more example. CH3 CH2 OH. Now here if you see the bond connectivity, this hydrogen, it is attached to oxygen, so it will show one signal. Now these two methyl groups, if you see 2 protons, okay, these 2 protons, they are attached to the same carbon. Okay, so this entire CH2 group, okay, CH2 group, if you see, it is here, it is attached to oxygen, on the other side it is attached to methyl group. So this is a different proton. Okay, chemical bonding is different, so chemical environment is different, so it will show one more signal, that is second. And the methyl group, if you see, it is attached to CH2. Okay, it also has a different chemical environment or different bonding, so this will be 3. Okay, so in this molecule ethyl alcohol, how many signals we will see? 3 signals. Okay, one signal of 3H, another signal of 2H, and one more signal of 1H. Okay, this OH generally doesn't show a peak in NMR, that we'll see in the next video. There is a concept called as deuterium exchange, there we will see, but just for a theoretical purpose we can assume that here OH will show a NMR peak. Okay, sometimes it does not show. Okay, so this is one more example, and the second important thing is a plane of symmetry. Okay, knowing whether a molecule has a plane of symmetry or not, that will make things more easier. For example, CH3 C double bond O CH3. Now if the plane of symmetry is present in any molecule, then the groups on either side, then the group of proton on either side, they are what? They are chemically equivalent. Okay, now let us understand what is the meaning of this. Now suppose in this acetone molecule, you can see here there is one plane of symmetry that is present. So this methyl and the methyl on the other side, both are what? They are called as chemically equivalent, and we will get only one signal. Okay, this is another way of identifying whether they are present in same or different chemical environment. Okay, if you see the bonding also, that is also same. Methyl is attached to carbonyl carbon, other methyl is also attached to the same carbonyl carbon. So they will give one signal of how many protons? 6 protons. Okay, let us take one more example and then we'll move on to the next topic. Okay, epoxide. So here again, here you can see there will be one plane of symmetry that will be present. Okay, if I draw a plane like this, okay, here there are two groups, that is CH2, this and the other CH2, both are what? They are chemically equivalent because plane of symmetry is present. Okay, so here we will get how many signals? 1 signals of 2 plus 2, 4 protons. Okay, so these are the two methods by which we can calculate the number of signals. First, you have to check the chemical bonding. If the bonding is same, they will show same signal. If the chemical bonding is different or bond connectivity is different, then they will show different signal. Another way of identifying is by drawing a plane of symmetry. If the plane of symmetry is present, then groups on either side, they are called equivalent, chemically equivalent, they will show same signal. If plane of symmetry is not present, then they will show different signals. Okay, now let us understand another concept, that is integration ratio. Now what is the meaning of this? So basically it decides, what does integration ratio decides? First of all, what does it depend on? It depends on the number of protons present in a group of protons. Okay, group of protons. Suppose there is okay, let us take example of this CH3, CH2, OH. Now here first let us count the number of signals. So is there any plane of symmetry present here? Answer is no. If you see the bond connectivity, this methyl and this methyl, okay, all these three methyls are attached to the same carbon. So bond connectivity is same. So this will show one signal. Now if you see this CH2 group, one side there is this tertiary butyl group, another side there is OH. So this will show another signal, and the OH is completely different. So this will show one more signal. So total there will be 3 signals. And integration ratio means you have to count the number of protons. Now in red group of protons, there are how many hydrogens? 3, 3 plus 3 plus 3. So 3 plus 3 plus 3, 9. So the integration ratio will be 9:2. Then for the orange one, this one here, there are how many protons? CH2 has 2 protons. Okay, and then OH has 1 proton. So 9:2:1, that is the integration ratio. Okay, we'll see in the next slide the intensity. Let's say this red protons is A, CH2 is B, and OH is C. So OH, since hydrogen is directly attached to oxygen, its chemical shift will be higher. In the last video of chemical shift, we had seen that this will be most de-shielded because of the electronegative atom. So it will experience maximum magnetic field and its chemical shift will be maximum, and only 1 proton, so height will be lesser. So this will be A. Then B, it is 2 protons, so double of A. Okay, and the 9 proton, it will be very tall like this. Okay, this will be C. So in this way you see the height. Okay, height, what does it depend on? It depends on the number of proton in any particular group. Okay, now let us understand this better with the help of some of the examples. Okay, now here if you see this methyl group and this methyl group, is there any plane of symmetry present? The answer is yes. So both of them will show one signal. Okay, of how many protons? 3 plus 3, 6 protons. Okay, since there is only one signal, so there will be no integration ratio. Integration ratio, for ratio there should be at least 2 different group of protons. Okay, next one. Here, is there any plane of symmetry present? If I draw this, is there plane of symmetry present? The answer is no. So all 3 are different groups of protons. So this will be, let's say A, this will be B, This will be C. Here both were same, so AA. So here we will see how many signals? 3 signals. Okay, and what will be the integration ratio? A, there are 3 protons. B, there is 2 proton, and in group C, it is 3. So how do you write the ratio? The bigger number to smaller number. So the integration ratio will be 3:2. Okay, it is just basically a simplest ratio of the number of proton present in particular group. Okay, now this one, here again there is no plane of symmetry, so this will be A, this group will be B, this group will be C. Again there are 3 signals. Okay, what will be the ratio? 3:2. In B there are how many protons? 2. In C again there are 2 protons, so 3:2:2. Next one. Now here if you see this CH3 and this CH3 both are attached to the same CH group. Okay, so they are equivalent. Okay, or you can draw the plane of symmetry. Plane of symmetry is present. Okay, so both are equivalent. So this will be A and CH will be B. So total there will be how many signals? 2 signals. What will be the integration ratio? 3 plus 3, 6. 6:1. Okay, and in this one, okay, let me erase this. Now here again, these 3 methyl groups, they are attached to the same carbon, so they will be A, and this CH3 you can see it is attached to oxygen. So this will show different signals. So there will be how many signals here? There will be 2 signals. 2 signals, and what will be the ratio? 3 plus 3 plus 3, 9. 9:2, and here it is 3 protons. So 9:3, divide by 3, simplest ratio will be 3:1. Okay, so in this way, these are some of the simpler examples. Now, suppose this one, here again you have to see the chemical bonding in alkene. Okay, this hydrogens I can write like this. Okay, or I can draw this molecule like this, CH3, C, CH3, double bond, C, H and H. Now you have to see again the chemical bonding. CH3 attached to carbon, but again you have to see the stereochemical relationship here. Means what is this methyl group is in which environment? It is cis2 hydrogen and cis2 methyl group and trans2 hydrogen. Similarly, this methyl group, another methyl group is also having same environment. Okay, or you can directly draw plane of symmetry. Here also you will see, is this a plane of symmetry? No. Then which plane is present here? If you draw a plane like this, so this will be A, this is a plane of symmetry, then both these hydrogens are also, this will show another signal. So there will be 2 signals. What will be integration ratio? 6:B, there are 2. So answer will be 3:1. Okay, now let us see one more example. Here, this hydrogen is 2 Br. Okay, both the Brs and trans 2 hydrogen. Similarly, this hydrogen also has the same chemical environment. Okay, if I draw a plane like this, then you can see there is a plane that is present. So both are equivalent. So here we will see one signal of 2 protons. Okay, this is a very interesting example and important. Okay, now for this one, if you just see the chemical environment, you might say this is 1. This methyl is attached to nitrogen. This methyl, another methyl is also attached to nitrogen. So 1, let's say this is A, and you might say this is B and this is also B. And if you write that there are 2 signals, your answer would be incorrect. So in this case, in the next one more example we'll see. Here what is happening is, H C double bond O N CH3 CH3. So here what is happening is there is resonance that is present. Okay, so because of resonance, what will happen is double bond C CH3 and CH3. Sorry, here there is nitrogen. Okay, and plus charge. So here now if you see the chemical environment, this hydrogen is simple, it will give one signal. Okay, it is having different chemical environment. Now this methyl, if you see here, it is cis to oxygen and trans to hydrogen. Okay, cis to oxygen and trans to hydrogen. But if you see the other methyl group that I will draw in blue, here if you see this blue one, this methyl is what? Cis to hydrogen and trans to oxygen. Okay, so both these methyl groups are not equivalent, they are different. So both will give different signals. So total there will be how many signals here? There will be not 2 signals, but here we will see how many signals? 3 signals. And what will be the integration ratio? Integration ratio will be total 6 protons. Okay, but they are all different. So 3 is to 1. Okay, 3 signals in the ratio 3 is to 1. Okay, similarly in alkenes we know here also if you write, let's say these 2 protons are having one signal, this one will be B, and if you write there will be 2 signals, the answer will be incorrect. Here again hydrogen, double bond H and Br. So here also if I see the chemical environment, this red one, it is cis to hydrogen but trans to bromine. And if I see the other hydrogen, this one is cis to bromine. Okay, red one is cis to hydrogen. So both are in different chemical environment. Okay, and orange is trans to hydrogen, but the red one is trans to Br. Okay, both are different, having different chemical environment. So this will give one signal A, this proton will give another signal B, and this proton will give another signal C. Okay, so here also you will see 3 signals. What will be the ratio? 1 is to 1. Now this example also, suppose you write 1, 2, 3 and CH. 4 signals, your answer would be incorrect. Okay, so what will be the correct answer? So here again you have to draw the other protons as well. So here above the plane there is one hydrogen, below the plane one hydrogen, above the plane hydrogen, below the plane hydrogen, above the plane one hydrogen, below the plane another hydrogen. Okay, so here now is there any plane of symmetry that is present? The answer is there is one plane that is present if you draw a plane like this. Okay, so this proton and this proton, they are equivalent, and this proton and this proton, they are below the plane. Okay, so they will be A, B, 2 signals. Now I will draw another plane and you have to tell me whether this is a plane of symmetry or not. Blue one, is this plane of symmetry? The answer will be no, because here you have Cl, but on the other side there is no Cl. So this hydrogen will give different signal because it is cis to hydrogen and trans to chlorine. This below the plane there is Cl, but for the C, this one, there is no Cl on the above the plane. So this will also give another signal D, and this hydrogen at the top, this is completely different. So this will give another signal E. So total there will be 5 signals and not 4. Okay, what will be the ratio? 2 is to 1:1:1. Okay, so A, these two will give one signal, B second signal, C above the plane different environment because here there is hydrogen. For D it is cis to chlorine, C is cis to hydrogen, that is why C and D will give different signal, and E, this one is again completely different. Okay, so total there will be 5 signals. Okay, so let us understand this one with an example. This is the example for integration ratio. So for 9 protons, the green one, you can see the height is how much. Suppose this is 9 centimeter. Okay, and this is 3 proton. So the ratio is 9:3. So the height of this will be how much? 3 centimeter. So height is relative. 9 centimeter for 9 protons. So 3 centimeter will be for 3 protons. Okay. Similarly, in this another example also you can see this brown one. Okay, 9 plus 9, 18 protons. So suppose this is 18 centimeter height for 18 protons. Then compared to this, you can see the orange one, this signal is for how many protons? 3 protons, it is shorter. Then is the green one. So you can see the height, orange is larger, green is slightly shorter. Green is for how many protons? 2 protons. And the red one is the shortest, that is for 1 proton. Okay, that is this OH. So in this way, the height of the peak depend on the group of number of hydrogen present in each group. Now let us solve some of the previous year questions that were asked in the JAM exam. So the first question is the magnetic field strength required to excite isolated proton to its higher spin state with the electromagnetic radiation. So the frequency is given. Okay, Larmor frequency is given to us, that is 300 megahertz. Now if you see the other quantity here, the magnetic gyromagnetic ratio, here they have given in second inverse. Okay, hertz means second inverse, but here we have megahertz, so we have to convert this into hertz. So mega means 10⁶. Okay, and hertz is nothing but second inverse. Then what else is given? Value of gyromagnetic ratio, gamma, is 26.75 into 10⁷ radian Tesla inverse second inverse. Then what other values you must know? Pi. Pi is how much? 3.14 radian. Okay, and what we have to calculate is the magnetic field B0. And what is the formula? Formula for Larmor frequency is gamma by 2 pi into B0. Now what are these values? We had seen in the first video of the basics of NMR spectroscopy. What is gamma? It is Larmor frequency, also called as precisional frequency. Okay, this is new. Okay, new, and this is gamma. This is the gyromagnetic ratio. Gyromagnetic ratio. Then B0 is the external magnetic field or field strength. Unit of this is Tesla. So we want B0. So now we have all the values, so we can just substitute and find out the value. B0 will be cross multiply nu into 2 pi divided by gamma. What is the value of frequency? 300 into 10⁶ second inverse into 2 into pi value is 3.14 radian. Okay, divided by value of gyromagnetic ratio 26.75 into 10⁷ radian per Tesla per second and radian per Tesla per second. Now if you see the units, second inverse get cancelled, radian get cancelled, Tesla inverse will go to the numerator, it will become Tesla. The final answer comes out to be 7 point. See the instruction very carefully. 2 decimal place. So it will be 7.04. Okay, the answer comes out to be 7.04, and the range that they've given is 7.00 to 7.10. Okay, so our answer lies in between this, so it is correct. Okay, so be very careful about the instruction up to 2 decimal places. Now this first one was asked in JAM 2019. Second one, this is asked in JAM 2018. Question is, this is numerical answer type question. So for the following hydrocarbon or carbon, how many of them would give rise to 3 group of proton? That means they are asking which one will show 3 signals, and the integration ratio should be 2:2:3. So now here first molecule, let's say this is A, or let's say this is 1, this is 2, and this is 3. So in the first molecule 1, is there any plane of symmetry here? The answer is yes. Here there is this plane of symmetry present. Okay, this CH2 will show one signal A, this CH2 will show another signal B, and this methyl will show another signal C. So what will be the integration ratio? A is to B is to C. Okay, so first condition, 3 signals satisfied. Ratio is 4:2. B, how many proton? 2 plus 2, 4. C, how many proton? 3 plus 3, 6. So ratio is 2:2:3. So this molecule is satisfying. Okay. Second one, here is there any plane of symmetry? You can draw plane like this. So this methyl and this methyl, they will show one signal A. This CH2 another signal B. This CH2 will show another signal C. So again the ratio will be 3 plus 3, 6. 6:2, 4:2, and CH2, that is 2. So what is the ratio? 3:2:1. Okay, so first condition satisfied 3 signals. Ratio is not matching. 3:2:1. We want 3:2:2. So second one does not satisfy. Now third one, is there plane of symmetry present here? The answer is yes. Okay, so this methyl and this methyl A, CH2 B. Okay, and there is one more plane of symmetry present, that is this one. So all the benzene proton, 4 proton, they are what? They are equivalent. Okay, so 4 proton will show C. So A is to B is to C. What is the ratio? A, CH3, 6 proton. B, there is CH2 plus CH2, 4. And C, there is 4 protons attached of the benzene ring, 4. So 3:2:2. So third one is also satisfying. So 2 molecules are satisfying. So what will be the answer? The answer will be 2. And if you see the key, the answer written is 2:2:2. That means if you write any answer other than 2, your answer would be incorrect. Okay, the last one, calculate the number of signals in P and Q. Now here, is there any plane of symmetry present? The answer is yes. This is the plane of symmetry that is present. Okay, so this one will be A, this one will be A, this will be B, B, and this methyl will be C. So in P, there are how many signals? 3. Q, is there any plane of symmetry present? No. These 2 methyl, they are what? They are same environment attached to CH. This CH will be B, this will give C, and this will be D. Okay, so total there are how many signals? 4 signals. So Q is showing 4. Question asked is P and Q respectively. P is 3, Q is 4. Answer will be A. 3 and 4 respectively. Okay, so that's it for this video. I hope you have understood some of the very important concepts. Okay, many a time these questions are asked. Very important, you should know how to find out the number of signals in 1H NMR spectrum. Okay, similar is the thing for 13C NMR spectrum also, that we'll see in the coming videos. Second one, the concept of integration ratio is very important. Okay, then the formula for chemical shift, we also saw one numerical based on that. That formula is also very important. Questions are directly asked many a times from that formula. Okay, and this one especially that we saw today, NN dimethyl formamide, this molecule is asked 3 to 4 times in JAM paper. In a lot of previous year question, this same molecule there was number of signals 2 or 3 times repeatedly in JAM paper. So it's very important. A number of signals they ask in almost every paper, whichever paper you take, GATE, NET or TIFR. Okay, so I hope you have understood both these topics: how to calculate the number of signal, how to calculate integration ratio, how to determine the value of chemical shift. We had seen in the last video about the factor affecting that, and the formula, how to use the chemical shift formula. Thank you.